Hi, sixth grade students. So bear with us as we're trying to figure out how to teach you some of the mean, median, mode, ranges, frequency charts, some of the things that show up in our last textbook of the year. We're doing our best today to be able to show you how to do some of these topics using the smartboard, using some charts we made. And we know that you might not physically be here, so we brought you with us. So you know who you are, find yourself in this set of students. And what you're going to see is underneath every single one of you, we have your height measured. Now this time your height is measured in centimeters. And the first thing that we wanted to show you is something called frequency charts. So I made a frequency chart here that is much like the tables we were doing in the variables and patterns book. You will see kind of like that X and Y that we've seen before. We have heights of all of the students measured in centimeters. And we have the number of students. I want to point out a couple of things to you. For example, the height of 4 students was 4 centimeters. Sometimes you will see these written as tallies. So 1, 2, 3, 4. If we happen to have a 5th one, we would have crossed it and then moved on to the next. So you will see both the tallies and the written number. You will also notice that no students had 5 centimeters. But a lot like what we did in the variables and patterns book, even though like this would be our independent variable, every single one was listed, even if we don't have data values for them. We have quite a range. Range is something that we'll talk about later, but we will see that the tallest student and the shortest student are both listed on here. So we go all the way from 4 centimeters all the way down to 39 centimeters. And it's called a frequency chart because it's the frequency of this data happening. So we can see for every single one, for example, 11 centimeters had 4 students, but we had many 1s, 2s, and 0s as well. Now this took up a lot of room, and those frequency charts can be really big. So a lot of times they make frequency charts that kind of shrink up the data. It has the exact same data, but this time we're giving them in ranges instead. So if I took the heights that were from 0 to 9 centimeters, 0 to 9 centimeters, that's this group of data. Rather than having it split out among different, every single one being listed, I can say that all of the students that were 0 to 9 centimeters, there was 8 of them. You can see that here, from 0 to 9, 8 students total. Then I can have another break of 10 to 19. That would be 6 students. And 10 to 19, we can see here is 4, 5, 6 students. 20 to 29 centimeters is 20 to 29 centimeters here, and we can see 4 students for that. And lastly, our students that are 30, way down there at the bottom, 30 to 39 is 3 students. So these can definitely shorten it up. Downside of this though, remember how we were talking with like graphs and charts, and sometimes that it is challenging on graphs to not know an exact data value? That same thing happens here. For 0 to 9 students, 0 to 9 centimeters, that's 8 students. But I don't know by looking at this range if all 8 of those had the same data value. I don't know if maybe they're all at the 9. Maybe I have them split up among it. I just know there's 8 students. So a downfall of this, I don't have specific data. A positive of this, I know specific data and how many for every single one. That's all that I can think of off the top of my head for frequency charts. I think that we can try to do a couple of these on IXL. So on the smartboard, I pulled up the IXL that we're going to ask you to do for this particular lesson. This one has graph information and the information on a frequency chart. I am looking for 80 to 100, and 81 to 100 has 2 students. So in that blank, you will mark a 2. But now I have to count them out. I'm looking for 100 to 119 students. I got lucky on this IXL. This IXL already has them in order. So I see 5 students that are somewhere in the range of 100 to 119. For this one, I'm looking for the number of pieces of pepperoni between 8 and 9 and how many pieces or how many pizzas that would be. This time, the IXL did not give them to me in any particular order, so I have to be careful with my counting. 8 to 9, that would be this one and this one. There's only 2 of them. I'm going to jump a level. And those are basically the things that we did. Let me keep on jumping up a level. Now this is called a dot plot. One of our future lessons are going to be about dot plots, but I think that you'll be able to get the gist of it from this picture. I have 2 to fill in. It was eaten 1 time by 1, 2, 3, 4, 5, 6, 7 people. And it was eaten 2 times by 2 people. Oops, 2 people, okay? I'm gonna jump a level one more time. Oh, there's no more levels to jump, so this is as hard as it's going to get. But I will have to fill in every single one of these. So I'm gonna come over here for a minute, and I can see that 20 to 59 is actually going to make me look at 2 categories, if you can see my mouse moving here. So altogether, I see 90 puns, 60 to 99. I also see 90 puns, 100 to 39. I see 50 puns. And then this one also has 2 categories. 30 and 50 will be 80 puns. I do remember that there was one thing that I forgot to show you when we were back at our diagram, so I'll bring you over there in a second. But this is important to see here. This is a great example. 15 to 19, that is split up into groups of 5. 20 to 24, 20, 21, 22, 23, 24, into groupings of 5. 25 to 29, 25, 26, 27, 28, 29. All of these are evenly spaced. And if we come back over here to my original data, I did the same thing. From 0 to 9, be careful with your counting, 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 10 pieces of height data. 10 to 19, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So each of these are 10 centimeter groupings. A common mistake that we see 6th graders make is they just do the subtraction of 19 minus 10, and they think that they only have them broken up into 9 sections. But if you're including that number itself, we're talking about 10 pieces of data for each of those. The other part of today's lesson is talking about outliers. An outlier is when a piece of data does not seem to fit in with the rest of the set. So for example, 4, 4, 4, 4, 6, 6, 6, and 29. That 29 doesn't fit in. Another example, 11, 29, 29, 31, 36, 39. That 11 doesn't fit in. They would be called the outliers. It's the piece of data that doesn't match the rest. So I want to show you this with the height of our students. I have 4 students that are 4 tall. I have 3 students that are 6 tall. And then if I were to have a student that was 29 tall, we can visually see that Barbie here is an outlier because her data just doesn't seem to fit in with the rest of the student population. I could also show that, so the large number is the outlier, but the outlier could also be the smallest number. So I'm gonna have a Ninja Turtle, and then 2 Barbies, and then let's bring in Woody, Jessie, and Buzz. So in this data set, I'll keep them organized for you from least to greatest. And this data set, Woody, Jessie, Buzz, and the Barbies are quite tall, but the Ninja Turtle is quite short. So the outlier can be on the lower end of the data too. It doesn't have to be on the higher end of data. A great real life example of outliers would be if we were to talk about income. For example, the money that a teacher makes, the money that a construction worker makes, the money that a computer worker makes. And then we put Elon Musk into the equation. Mr. Musk makes a substantial amount of money. So in comparison, we have typical wages of typical jobs that our families might have, And then Mr. Musk, multi-billionaire. His data doesn't fit in with the rest. So that's a little bit about outliers. We'll finish up by looking at the IXL for outliers, and then that'll be the end of today's lesson. So the outliers in this IXL, we can see we have a lot of large numbers from the 30 to 52 range, but 2 does not seem to fit in with the rest. We can see a lot of smaller numbers. Okay, so 11 to 50 is quite a gap, but then once again, we have one that just does not fit in with the rest. A lot of large numbers, 69 to 98, but 4 is substantially smaller than the rest. He is the outlier. 33 to 83, we've got some 10s, but all the way up to 699, that would be your outlier. Let's jump some levels. Let's see if they get any more challenging. Oh, so what makes this one a little bit more challenging is that they've now scrambled the numbers. We just have to look carefully to find the outlier. So we have what looks like from about 65 to the upper 80s, but 7 is the one that does not fit in with the rest. We'll jump another level. And now we just have to be careful with our findings. It might be easy to overlook that this one is in the thousands place instead of in the hundreds place. And there's another level to jump to. This one might be a little bit harder to see because they're all in the tens places. However, we have lower tens places, but a very upper tens place. So there is your information on outliers and frequency charts. We hope that you have a good understanding of this. We'll try to take some snapshots of the pictures for you, and we will have these IXLs posted.